Let's have a look at relative position and an example where we want to find the shortest distance between two boats with positions expressed as vectors RA and RB relative to a port at the origin, where we have our A vector as 2 plus 2.4t and 5 minus 3.2t. So 2.4t is the velocity vector. And so that's the velocity, 2.4, 3.2. And 2 and 5, that's the starting position. And RB, the other boat, 3 plus 2t and minus 2 plus t. So we want to find the shortest distance, and if we can think of an expression for the relative position of boat B in relation to A, we can write that as RB minus vector RA. So that would be boat B relative to boat A. And we can express the distance between the boats as the magnitude of that vector. So we can start by doing this calculation here then. So RB minus RA is going to be one vector subtracted from the other. So this is B vector, that's 3 plus 2t, and then we subtract A vector minus 2 minus 2.4t. The y component of B vector is minus 2 plus t, and then we subtract A vector 5, and then it's going to be plus 3.2t because the last part of that y component is negative. Here we have 3 minus 2, that's 1. And then we have plus 2 minus 2.4t, so that's going to be minus 0.4t. And the y component is going to be minus 7 plus 4.2t, like this. Okay, so now we have an expression for the distance between the two, but we want to find the shortest distance. Actually, if we want the magnitude of the distance, we have to take the square root of the sum of the squares of the components. So this is going to be a complicated expression looking like this. And we would want to do this on the calculator. So this is where we use the Casio. So let's go to the calculator, and if we go into the menu and then the graphing menu, we can type this in. So we start by taking, okay, we want the square root, and we have to sort of fence in our expression here. It's going to be 0.4, and t, the variable button is this one, so it'll come up as x, but that doesn't matter. we want to square that first parenthesis, and then we add the other one, and that's going to be -7 plus 4.2 t, and then square it. And then end bracket. So we have two brackets here, one nested within the other, because the outer one makes sure that everything is underneath the root sign. So enter that, and we can draw our function. And it looks like this. Let's see. We can take a look at our view window. Well, I mean, we have everything we need. We want to find the minimum value of this function. And that's going to be the lowest point on the graph. And so we can press Shift and G solve. That's GSLV F5, and go for the minimum value. And we can see that, okay, we get an X value 1.67, we get a Y value 0.33. We have the X for this function. Remember that X is T. So we have a T value, 1.67. So that's the time. And the function value is the distance, because this was a distance function. So the distance is 0.33 meters. And we can write that out here as well. So the distance, right, 0.33 meters. And the time when this occurs is 1.67. I don't remember if this was seconds or what it was. Probably seconds, yeah. All right. So there you have it.